Welcome. I'd like to take another look at an example, solving a system of equations using Gaussian elimination and back substitution. In this case, we're going to find that there are infinitely many solutions, and so that's the key thing that we want. However, of course, let's enjoy the opportunity for another example of Gaussian elimination. The goal is to get rid of the variables here, so that way we have a triangular form. That is the goal of Gaussian elimination, to get that triangular form, and then we can use back substitution. That might look a little bit weird because we're missing y and we're missing z here, but of course, those sorts of things will be introduced as we work through this. So what I'm going to do is I'm going to try to eliminate x from equation b. So we have a, b, c here. I want to eliminate x from here, so I'm going to subtract 2 times equation a. That's going to result in this new system. Equation a stays exactly the same as x plus 3y minus 2z, which is equal to 0. Equation b is the one that I'm manipulating. This minus 2 of those eliminates the x's. This minus 2 of those gives us negative 6y. This minus 2 of those gives us a positive 8z. And this minus 2 of those is 4. Equation c stays the same as 4x plus 6y is equal to 4. Again, label as A, B, C. I would like to eliminate the variable x from the third equation. Notice this could possibly be simplified by dividing equation c by 2, much like we could do for equation b. We won't worry about that for now. Some simplification will likely happen as we move along. So we're going to take equation c and we're going to subtract 4 times equation a. Equation a stays the same as x plus 3y minus 2z is equal to 0. Equation b stays the same as negative 6y plus 8z is equal to 4. And equation c is the equation that we are manipulating. 4x minus 4 of those is 4x minus 4x. That eliminates the x's. That was the desire there. This minus 4 of those, well, 6y minus 4 times 3. 4 times 3 is 12. So 6 minus 12 gives us a negative 6. We have negative 6y. And this minus 4 of those, negative 4 times a negative 2 is a positive 8. So that is a positive 8z. And this minus 4 of those is just 4. Equation A, equation B, equation C. Now, conveniently, the y's essentially match here. So I can eliminate this y by taking equation C and simply subtracting equation B. Now, I haven't thought about anything too hard, but of course we can see what's going to happen here. With equation A and B staying the same, I have x plus 3y minus 2z is equal to 0 for equation A. Negative 6y plus 8z is equal to 4 for equation B. And equation C, negative 6y minus a negative 6y, of course, eliminates the y's. However, 8z minus 8z also eliminates z, and 4 minus 4 also eliminates the constant. So we end up with 0 is equal to 0. Our third equation does not give us a specific value for z. Z can be anything we want. Z can be 10, and 0 will still be equal to 0. So we have this free variable. So we say z is a free variable. If z is a free variable, we can let it be anything we want. And so we use what we call a parameter to hold the place of z, which seems weird because we're just using a different letter to represent to be the value of the variable z. So we're going to let z be equal to t. Sometimes books use s, sometimes books use something different, but it's very common for t and s to be used. Really, you could use any letter you want except for x, y, and z. So we're going to let z be equal to t. Why do we do this? Again, z is the variable that we are trying to find the value of, and t is what we call a parameter. We can choose any value we want for t. Once we have something for t, we still follow along with the process of back substitution to give us negative 6y plus 8t is equal to 4. I can subtract 8t from both sides to get negative 6y is equal to 4 minus 8t. I can divide by negative 6 to get y is equal to 4 minus 8t divided by negative 6. If you would like to show some work here, we can pull out the common factor of 4. Well, all we really want is the common factor of 2 in the numerator here. Maybe we would like to have the negative 2, though. So we're left with 4t minus 2. When you pull a negative 2 off of 4, it becomes negative 2. When you pull a negative 2 off of negative 8, it becomes positive 4. So I wrote it in this order because that's convenient. 6 I can express as negative 2 times 3. I have a cancellation of the negative 2's, and I am left with 4t minus 2 divided by 3. And that's convenient. We like that. This allows us to plug the value of y and z into the first equation. X plus 3y. Y value was 4t minus 2 divided by 3. That's nice. Those cancel out. Minus 2 times the value of z, which we said is t, and this is equal to 0. So I have x plus the 3's cancel, so I have 4t minus 2 minus 2t is equal to 0. 4t minus 2t is 2t, so I have x plus 2t minus 2 is equal to 0. And now I can subtract 2t and add 2 to both sides to find that x is equal to 2 minus 2t. My solutions then are x, y, z is equal to 2 minus 2t. My y value I found to be, where did that go? 4t minus 2 over 3. And my z value I had as t. Now, if I plug any specific value in for t, that will give me a specific solution, but this is the desired general solution.